making quick videos to explain some of the key concepts for each guided reading question or GRQ. This is the first one. So you do not have to watch the videos, but for those of you who are auditory learners, these may be helpful. So for the first GRQ, Anatomy Basics, our main goals are to define anatomy and physiology and relate feedback loops to the concept of homeostasis. Finally, you're going to learn some common vocab for directions and body regions. Anatomy is the structure, while physiology is considered a function. And for a non-biology example, let's think about an oven, something that I have been using quite a bit recently. The anatomy of an oven, the structure of an oven, well, that's like the metal box and the heating coil that's inside of it, and it's got a thermometer and it's got vents that move that hot air around. The function of an oven is obviously to heat things at a consistent temperature, hopefully. And as with all things, structure relates to function. The oven is able to perform its function of heating things because of its structures, because it has that hot coil that will raise the temperature, and a thermometer to measure the temperature, and vents to move that hot air around to cook things evenly. Structure relates to function. The same is true in biology, and this is a theme of structure and function that we're going to return to over and over again. The next major concept is the idea of homeostasis. Homeostasis is when the body works to keep a stable and steady internal condition for a key parameter, something like body temperature or blood sugar. Our body is at an ideal set point. With temperature, for example, our body's homeostatic set point is 98.6 degrees Fahrenheit. When the body's internal condition moves away from that ideal set point, we'll use feedback loops to bring it back. So again, with temperature, in a negative feedback loop, once we've detected the change, the message is sent to a control center, and then the body will take action to bring that parameter back to its set point. Will shut off. So in a negative feedback loop, once we're back to our ideal set point, the loop turns off. So for body temperature, this means that if you start to overheat, as is typical in a North Carolina summer, your brain is going to tell your body, okay, it's time to sweat more. We got to bring our blood to the surface of our body to cool it down. And we're going to slowly start to bring our body temperature back to our ideal point, 98.6. When it reaches this, your brain is gonna tell your body to stop sweating, and it's gonna bring the blood back to where it's supposed to be, so you won't be so red. And if this didn't happen, if the negative feedback loop didn't turn off at the end, you would keep lowering your body temperature below that set point. You'd get too cold. So this is why negative feedback loops are so important, that they shut off once they reach that ideal spot. Positive feedback loops are a lot more rare in human biology. This is when the loop doesn't shut off, but it just keeps going and going and going. And the main example that you're going to see everywhere is childbirth. Now, this is something I have not experienced firsthand, so this is all secondhand information. But apparently, when you go through the act of childbirth, your contractions as a woman start off far apart and mild, and they get closer together and stronger and stronger and stronger. So it's not that you have one contraction and then the system shuts off. No, in fact, the system keeps going. You have more and more and more. This is usually the only example people give for positive feedback. Other examples have to do with plants, and I'm not a botanist, so we're not going to discuss plants. Finally, GRQ1 asks you to learn about the organ systems and some terms for body parts and directions. These are mostly straightforward, but they're going to require that you spend some time making flashcards or a Quizlet to practice these terms. The ones that give people the most trouble are the difference between proximal and distal versus superior and inferior. Remember, we use proximal and distal for on the limbs only. So proximal means closer to the site of attachment, my shoulder being the most proximal thing on my arm, it's closest to my body, and distal being furthest away. So in this case, my fingers are the most distal part of my arm, furthest away from where the arm attaches to the body. Whereas superior, inferior, we use for the head and trunk. So my head is superior, my butt being inferior in this example. The other thing to keep in mind is that these directions refer to the body in anatomical position. So body erect, feet facing parallel, hands, palms facing forward. Hopefully that is a good review of some anatomy basics, and stay tuned as we move up the levels of structure, starting with chemistry.